There's a request I have regarding in previous assignment. Means I was able.
Okay. Okay, so I will turn off my video. I think that was causing trouble last week. Okay. So, yeah. It would have been nice with the video, but I somehow cannot reduce the quality of video here. If there was an option, it would have been easier. Okay. So, yeah, just to begin, a couple of announcements. And so today we'll be talking about inheritance. There were complaints about the first assignment test cases. So we just checked it. So assignment one. So all test cases are within the constraints. Okay. So somebody were complaining about long int or long int and so on. But yeah, so we will not accept that because the parameter constraints that we have given, so the test cases satisfy that. That's what we wanted to check. So all test cases are within the constraints.
So, but sir, means like some people who joined from other language, they might not know about long it. So if you could consider, it would be nice to consider it.
No, will not. See, we're sorry. Okay, so the requisite is PDS, so you will have to build the background from there. Okay, it's your
Okay, sir.
responsibility. So all functionalities of C should be known. You cannot excuse that. So you have agreed that you
Okay,
will
sir.
learn that. Okay, so that's it.
But sir, it's really minor details. Sir. It's really minor details. So to go in, like Python take care of it that thing itself. So we are not bound
See,
to look out
we are
that.
not responsible for Python, man. So don't bring in Python, okay? So please,
Yeah. Okay, sir. Thank you. I
see,
understand.
that's what I'm saying. I mean, we have announced this is C++, and people are required to know C. That's it. Period. Okay. You cannot help beyond that in this particular. So it's your responsibility to learn about it and pick up. So this is only a small nuisance. Okay, it's not going to be really big thing. So it's better you rectify it immediately. Okay. So yeah, so within the constraints given, so no uh, further considerations, whatever. So since we gave the range of values, right? So it is clear what data type you should use. So that is it. Because we didn't specify any data type. So that's the main thing. Okay. So in the assignment, we are not specifying the data type. So it is your choice. You have to see what are the constraints given, what is the value of n or n square or whatever. So it should satisfy. That's it. Okay. Okay. Okay, so a couple of points. So, yeah, so in the last lecture, there was some issue about this commutativity of operators. So I did not answer the question. Okay, so particularly, I mean, this problem occurs when you have operator plus with the one as some class, say, yeah, let's say, what was it, num class, and other one was int. That's what our example was. Okay. Yeah, so here, if you want it to be commutative, should always declare it both ways. Otherwise, it won't work. No matter where you declare it, inside the class or outside the class. Okay. So if you are defining it as a homogeneous operator, that is, operands are of the same type. So if you are saying plus num, then of course it is commutative. Okay. So it is treated as commutative. It just works the way, or star num. I'm assuming num as a class, user-defined class. Okay. Yeah, so that is something we need to keep in mind. It automatically does not apply the commutativity rule for, of course, obvious reasons. Okay, because once the data type is heterogeneous, right, it does not make sense to have commutativity enforced right away. Okay, so C++ is not that intelligent. So yeah, so that is something that we need to keep in mind. Okay. So both needs to be declared. So that is all. So any questions? I'll just wait for a minute. Is there any clarification required or also further complaints of assignment? I'll be anyway taking a survey over this week to revise how assignments should be and so on. Yeah, so today's lecture is going to be focusing on, we are going to focus on the concept of inheritance. Okay, so it's one of the primary aspects in object-oriented programming, which is also supported in C++. Okay. So here, the idea is reuse of codes, or in fact, in this case, objects. Okay. So suppose, we built a class. Okay, so class maybe for fruit. Okay, so but then we decided that we want to have classes for say apple or banana or orange and so on. So then what we would like is all attributes of fruit available to these classes. Okay. So the concept here is called derivation. So then we call these classes fruit, so classes apple, banana, or orange as derived classes, derived out of the class fruit. So they will inherit all features of the class. Okay. So of course with certain riders, and depends on what is private, public, and protected in the class. Okay. So it's essentially the idea is to reuse of the functionality or code. Okay. So particularly when you build large software systems, so starting from scratch everything may not be really useful. So see in typical, C style, what you would have seen, procedural style, you would have seen is like reuse through function libraries, right? Yeah. So you build functions, compile and keep them in libraries, then reuse them. Okay, so that is one way of doing. But here we have the additional feature of objects or classes. So then if you define some class, okay, you can keep it in some library, but it could be that, like I said, just this example. So you have already say defined a fruit class, okay, but then you want to have objects with similar features of fruit, but with the additional features like apple, orange, banana, anything, okay. Whatever additional properties of these specific fruits you may want to include in those classes. But then you don't want to like really let go of, implement the whole things that you have done for fruit. You might have implemented certain procedures for it. This is not just about fruits. In general, any kinds of classes. Okay. So such process is called class derivation or inheritance in C++. Okay. Yeah. So here the parent class, we also call it as base class. Okay. So for example, this class, base class, has one function here. And yeah, so just for demonstration purpose, one data, which is, we keep it as protected. Okay. Now, so any class can be a derived class of this base class. Okay. So all we have to do is to declare a derived class. So we declare a class. So class derived. So this is the new class name. But we put a qualifier here. So we are saying that it is derived. So this is not a keyword. This is a variable name here. Okay, or a type name here. Okay, not a variable name. Sorry, it's a type name here. So we are saying that the class base is public. So this basically says derived is a derived class from the base class. That means it inherits all attributes, public and protected attributes of the class called base. Okay, so it's like you are including, so you can just imagine you are including all code that is built for base class inside here. But it's not exactly that. we will also be able to access the attributes of the base class as such. We'll see how to do it. Okay. So derived class, we also call it as child class, which inherits the properties of the parent class and defines its own attributes, data, function, everything. Okay. So that is, it can add any other functionality. So this is something like how it happens in our society, right? So how we inherit behaviors or styles of our parents, attributes of our parents, but we will also have our own attributes. Okay, so that, I mean, the thought process is essentially similar. Okay, so in this case, so base is a class type, derived is also class type. So you can declare variables of base as well as derived. So here, see, we just use the word base here. Base is not a keyword here. Okay, so it could have been any other class name. It's nothing specific about base. Just for our understanding, we have used the term base and derived. Derived is also not a keyword. So both of these are not keyword. So only thing here is you are saying that it is derived from base, which is public. Okay, so public basically means all attributes, all public data of base will also be public data of derived. All protected data of base will also be protected data, and all private data will be private data. But there's one more thing. So like we saw in the last lecture before that, all private data of base class will be not just private data, but they won't be accessible to functions, its own functions. So derived has function sum. Okay. So here it has function fun. So if we had declared, say here, additionally we said, sorry, say private int m. Okay, so now the function sum cannot access, so cannot access, it cannot access, only the base class functions can access it. So it can access it. Okay, so if you remember from the properties of public, protected, and derived, and this, sorry, not derived, private, this is what we had stated there, and this is what it means. I mean, at that time we didn't know what is inheritance, we didn't discuss that. Okay. So in today's lecture, we are going to discuss about issues arising out of inheritance, or what are the attributes or properties of inheritance that are useful in developing. Okay. So it's essentially, the idea is for code reuse, just like you build libraries. Of course, you can build libraries. With this has added features here, but this concept is essentially for classes. Okay, unlike just functions. Yeah, this is a schematic figure describing derivation. So this is the base class and this is a derived class. So employee is a general class for employee. So now you might want either executive officer or an engineer or a technical officer, whatever. So these could be, they might require additional attributes, but they also need all attributes of an employee. Okay, so these are derived classes. CEO, okay, and yeah, we are assuming that the context is, so in our context, we are also looking at IITM CS student entrepreneurs, and you can imagine it as a derived class. Okay? But IITM student will also have features of student. So student is a generic class, what all attributes of student, roll number, whatever, address, hostel, and so on. Now, in general, properties of a student, maybe for IITM student, we might have some specific additional features. So you can just imagine it as a derived class. Okay. For a CS student, maybe some more additional features might be required. Okay. Lab associated and so on. So this is IITM CS student. Okay. Now, if you want to talk about, if you want to have a class for a student entrepreneur, okay, then you can just imagine the class needs to have attributes of a CEO as well as IITM CS student. Okay, so then IITM CS student entrepreneur is a class derived from both. See here, when I say derived class, a class can be derived from multiple. So I can just say public base and then public another class name and so on. Okay, so that is that is allowed there. Okay. So derivation need not be from one base class, that could be from multiple base classes. Yeah, so we'll discuss what are the attributes that are inherent. Okay, so this is an important aspect. Okay. So one thing is all data. Okay, so all data, they are inherited. So an object of a derived class has stored in it all fields of the base type. Okay, so that is the field here was n as well as m. So the derived class, if I say derived d, so d will have m as well as n. Okay, and it has function fun and function sum. Okay, so there was no data we added to the derived class. I could have also declared another data here, say maybe um, int p. Okay, so this object will have the fields n, m, p, and then fun as a function, sum as a function. So these are the things which are available. Yeah, so similarly, the methods or functions can also be used from the base type. Okay. Yeah. So there are important things to keep in mind. Okay. Now you might have for the base class that would be constructors. Okay. But that is not enough. The derived class also has, it needs to have its own constructors if you want to initialize some data or whatever. Okay, or if you want to allocate some memory. Particularly constructors are useful to allocate some memory when you declare a variable of the class type. Okay, so yeah, many times, so you also need to, so see, if there is a default constructor, then that will be executed automatically when you invoke the constructor for the derived class. But if you, yeah, so if you have multiple constructors, overloaded constructors for the base class, then you will have to explicitly invoke appropriate base constructors. Okay. Yeah, and of course the access permissions will have to be respected. So the private data of the base class will not be visible to the methods in the derived class. That is the permissions, access permission. Okay. Only public and protected will be available or to all derived classes. So I mean, when I say derived classes, see, I can derive further. Okay, so nobody, so C++ does not stop me. So I can have, so derived, I can have double derived or say D derived with the derived as a public. Okay. So in that case, so all data that are available to the double derived will be the data of derived, the public, private, and protected, and the data of base. Okay, but the access, so only public of base will be visible to the double derived. Okay, the protected of base will not be visible. So remember, protected qualifier was basically such that all class which are immediately derived from that class will be able to see. Okay, but if you derive further, so do a double derivation, then the protected data of the original base class will not be visible to the double derived. Okay, so that is because double derived one is as such nothing related to the base class, even if there is a hierarchy of derivation. Okay, so that is something that we need to keep in mind. So C++, basically, I mean, its inheritance behavior is basically that. So that is grandchildren, right? So grandchildren will not be able to see the protected data of grandparents. You can just imagine that way. You're seeing these classes as human beings. Yeah. So that is, so here is a summary here. Yeah, all public methods and data of a class are visible to children and elsewhere. All protected will be only visible to children. Private will be only visible to the class. Okay, so it's only to children, not further. If you derive it further, it's not going to be children. Okay, so Any question? Okay, there were chats. Okay. So we'll release. Okay, so we are in the process of uploading it to the Moodle. I think there was a question about when will the marks of the assignments will be released. Okay, in a couple of days. It's a distributed process, so it will happen. Yeah. Any other question? Okay, how is the voice quality today? Is there any break?
No, sir, it's fine.
Yeah, but the number of attendance is only 70. So if it is going to be less than 100, we can as well switch to Google Meet. But anyway, we'll continue with this. And how was the recording? So there were some complaints. When I saw it, there were some places where there were some breaks, I think, but it was not that bad. But what I wanted to know is the size of the file a problem for anyone? Because I felt it was humongous file. I thought it was 250 MB. Okay. So if it is the case, then I will try to apply some compression algorithms. Okay. So let's come to the important aspect of constructors. Okay. So yeah, so it's important how they are executed. Okay. So one thing is, so if you have multiple constructors for if you have defined constructor for a base class, for the base class, you need to call them explicitly. Okay, so we need to call them explicitly. That is something very important we need to keep in mind. Okay, so a derived class constructor, if you define the derived class constructor, it has to call the base class. But how do you do you call it as a function? You don't call it as a function. This is how you do it. Okay, so the derived class. So this is the constructor with the two parameters. So the base class constructor has one. So what you do is you put a colon here and say base x. Okay. So if you have, so it is derived from multiple classes, then put a colon again, base 2x and so on, or base 2y, whatever. Okay. So you don't call it as a function. So that is something important here. This cannot be done using an executable instruction in the body of the constructor. Okay. You explicitly specify this is the base class constructor which needs to be called, but this is done by this colon operator. Okay, so put a colon and then call the base class constructor. After that, you put the derived class constructor. Okay, so one thing that we need to keep in mind is the order of constructor. So when you declare an object of the derived class, okay. So it will be the base class constructor which will be called first. Okay, so that's the reason why you cannot call it as make it as a function call. So if it is allowed as a function call, you could have done it anywhere, but the C++ programming guideline, it basically, so the rules basically say that, so when you construct or when you declare a variable of the derived class, the base class constructor will be automatically called first. Then you might wonder, okay, so if it is the case, then why should I do this explicitly? You need to do it explicitly if the constructor is not the default constructor. Okay, if you are having user-defined constructors, then of course you need to say. So particularly, if you have declared a constructor or multiple constructors, then you have to say which constructor needs to be called. Okay, you need to specify that. That's the reason why this explicitness is mandated. Okay. So yeah. So the order we need to keep in mind: base class first, then after that the constructor for the derived class. And the order reverses in the case of destructors. Okay. So the destructors get called in the reverse order compared to the constructors. Okay, so this is a base class destructor. Now, when you say for the derived class, it will call the base class destructor and then followed by the base class, I mean the derived class destructor. Okay, so in this case, it's basically the default, I mean without any parameter here. Okay, so you don't really specify what is the destructor. If there are multiple, then you need to specify what is the destructor called. So you'll have to put this colon here and then say which destructor to be called. Okay. Yeah. Okay, so I'm reminded of something. So I have codes for all these. Okay, so I'll share the codes in the Google folder. Today itself I remembered. I keep on forgetting. So all the codes that are used in the lectures, they are available. So I'll put it in the Google folder. Okay. In case I don't do it by today evening, so please don't hesitate to send me reminders. Yeah. So the next is going to be issues arising. So particularly, we didn't really discuss pointers. I mean, pointers work the same way as in C. Okay, except that you can also have pointers to classes. Okay. So now this inheritance, particularly, I mean, when you consider derived classes, so there are some good features which is available in C++. Okay, but they also give some complications. Okay, or some things that we need to keep in mind. Okay. So, I mean, one question would be like, okay, so how do you support pointers? Okay, so for a derived class, so can they be pointed by pointers of type base class, or is it that it has to be derived class? So, interestingly, C++ allows a base class pointer to point to a derived class. Okay, so I believe all of you are familiar with the pointer to structures, particularly when you implemented linked list in your PDS course. Those who haven't, so please revise. Okay, yeah, revise and then go back through this part of the lecture. I mean, at least the slides. Okay. Yeah, because pointers to structures is something important when what we. Oh, so there was a problem. Yes, Satvik, I missed your chat. Okay, so please open your mic and ask questions. Okay, because I may not be seeing the chat window. If I open the chat window, then I can't see my slides. So, okay, so there were more questions. Okay, so let me just look at it. Okay, how double derivation at, yeah, so double derivation. So like I said, I think I already clarified it, but let's do it again. So if you do double derivation, right, all protected data of the original base class, they will become private for the double derive. Okay, only the immediate children will see the protected data. Okay, the private data will remain private data. The protected data of the first level derived class will be available to the second level derived class. Again, if you go third level, then the protected data will become automatically private. So this is something important. Okay, so the protected data is accessible only to children, only to the methods of the children. Okay, so protected data only to children. So children of children, yeah,
So,
yes.
I mean, so if base is the parent class and derived one is the first derivation,
Yeah.
then protected, I mean, if I publicly derive it, then public variables will be public and protected, right?
Yeah. So the protected, the other kinds of derivation I haven't discussed. So I'm just
Yeah, if
looking
I'm
at the
publicly
public
deriving, yeah,
derivation. Yes,
yeah.
yes.
And
Yeah.
if I derive it again, then public will be again public and protected will
Public
be
will be
again
available.
protected, right?
Yeah, public will be, but the protected data of the original will not be visible. Okay. So further derivation, yeah. So that is the rest here. So protected is only for children. It won't go further. It will
But
remain private.
From the point of view of derived 2, derived 1 is parent, right?
Yeah, so protected of derived 1 will be available for derived 2, but protected of base will not be available for derived 2. It will be
But
private.
protected of derived 1 is protected of derived, right? Protected of base, sorry.
No, that is not how it is implemented. So the hierarchy does not go as far as I know. Okay. So
Okay, sir. Thank you.
it will be protected, but I think okay. So that yeah, at least from the books that I have seen, it is not like that. Okay. So yeah, maybe after the lecture we'll clarify. Okay, that's a good point you made. Yeah, it will be no. I don't think it is protected. Okay, it becomes private of the derived one. Is what I understand. Okay, so we'll experiment it after the class. Okay, so please.
Okay, sir. Thank you.
Yeah.
Yeah.
Satik, what was your point? Can you explain it again? 227.
Okay, sir. Right. Okay.
Oh, it is
My
Satik,
point
is
is
it?
that,
Okay. Yeah.
yeah. So I was telling that if we publicly inherit, then public variables of base will be public of derived 1.
Yeah, so public will remain public, but
Yeah. Protected remains protected.
that I'm not very sure. Okay, that needs clarity. Yeah, I mean it makes sense. The thinking makes sense, but as far as I know,
Yeah.
I think it's only one level. Okay, so
Okay, so I mean, so from again, if we do the same thing, then derived 2, public will be public and private will be protected, right? So in that sense, I was saying that the protected of base will be available to the derived 2. That was
yeah,
my
so
point. Yeah.
yeah, but if I understand it correctly, I think the protected works in a different way. I mean, so protected of children so from the grandparent. I mean, let's use the human terminology. Grandparent is protected of the grandparent will not be available to grandchildren. It will be private, is what I understand. Okay.
Okay, sir. Sure.
We'll experiment it. Yeah.
Yeah.
Okay. Yeah, so now we'll come to the important aspect, which is about pointers. Okay, so that is something that we are going to discuss now. So, like I said, there is a good feature about pointers. Okay, but there are also complications arising out of it. Okay, so yeah. So one thing that we need to remember is, unlike C++, unlike C++ has strong rules towards types. Okay, so you might have already experienced when you write your code and compile. Okay, so if there is type mismatch, it will immediately give an error. Okay, so unlike in C, where you might get only warning. Okay, yeah. So one thing here is. With respect to pointers, so remember that just like pointers to structures, you can also have pointers to classes. Okay? Now, one additional feature that C++ allows is, if you have base and derived classes, okay, a base class pointer can point to a derived class. Okay? So in general, say some arbitrary class pointer, say student class pointer, cannot point to banana class, assuming that they are not related to each other. Okay, yeah, so that cannot happen. But a base class pointer can always point to a derived class object. Okay, so this is a feature which is implemented. Okay, so for example, this code segment demonstrates that. So base class and then the derived, which has base as public. Okay, but I can do this assignment. Okay, so base pointer is assigned. So new, remember that it's a new, memory allocation procedure available in C++. Okay. So for any type, you can have new of that type. Okay. So new derived. Okay. So here you are also saying the constructor should be called. Okay. So when, not constructor, how many data or whatever. Okay. So leave that part apart. So here, this is allowed. So remember that these two are different classes, but this is a base class and this is a derived class. Okay, so hence this is allowed. Okay. So, I mean, okay. So what is exactly use of this? It is something like, okay, it's more making it handy for programmers. Okay, so you don't have to say whenever you derive a class. So if you just have pointer of the type for base class is good enough. Even if you have a derived class, so you can just make it point. Okay, that's a feature. That's probably something handy for programming. But there are complications too. Okay? Particularly look at this code segment. Okay? So I declare the pointer of base type, but assigned it a variable, I mean data space of the derived type. So this pointer will point to a data space and data space which has all the data attributes of derived as well as base, because derived is derived from base. Okay. But now when I call delete, so remember that delete always calls for the destructor. Okay. So it will call the destructor of the base. That is a complication. Okay. So if public had many data attributes here, okay, they will not be destroyed. That means their memory will not be released. Because when you call delete, you would not, so the program, I mean, the program environment would not know. See, at compile time, you cannot figure out, right, what has been allocated and so on. Okay. I mean, of course, you can say, okay, why not? Here I have said new derived, so the compiler should know. But you can easily modify this into a program segment where you do this following. Okay. So if input, say in is greater than 10, then so b is equal to, so I'm assuming that base is b is defined as a pointer to base type. Okay. B is new base, else b is new derived. Okay. If this were the code, at compile time you would not really know, right, which one first or which one is allocated. So the call for destructor will have to be of B only. So it has to, see, when you say call for destructor, it's done by the compiler, right? The compiler inserts the code for that. Okay. Which destructor to be called and so on. Okay. So that by default will be the destructor for B, right? Nothing else is possible. So, but that is a complication, right? If you had allocated memory for derived, but destructor for only for the base class, all data of base class will be left in the memory. They will be unutilized, right? It's a security hazard. There are lots of issues. Because if the data is not destroyed, I mean, the memory is, I mean, one is memory release, but also that if the data is also not destroyed there, then that is a major problem there, right? Because that data will be available to everyone. Once it is released, it is systems memory. Okay, that is one part. Second part is the memory wastage. You will not be able to utilize them. Okay, so that is a complication this feature has. Okay, so whatever the reason why this feature is introduced, the feature is basically, I think, the point is, I mean, if you derive some 10 classes out of a base class, so for, I mean, if you want to have dynamic memory allocation and so you want to have just one pointer, instead of declaring this 10 pointer variables, you can just have one pointer variable. And I mean, dynamically when you allocate memory, you can allocate to suitable class type. Okay, so that is the idea. That's actually a handy feature, but there is a complication. I hope everybody is clear about the complication here, right? Adding this feature introduces this complication. Okay, so now we'll see how to address that in the next slide. Okay, so what we do is yeah. So this slide basically says why such a feature is useful. Okay, so this basically done by the what is called as virtual. Okay. So what we do is, so we say, so there is a keyword called virtual. Okay, I'll talk about it a bit later. Okay, what exactly it means. Okay, so so what it says is like, so you can define any functions of a class as virtual function. Okay, that is specifically meant for inheritance. Okay, so that's specifically meant for inheritance. I'll tell you why virtual functions are useful or whatever. Okay, so we'll talk about that. So before that, talk about a way to cope up with this problem here by this introduced by this feature. Okay, so what you do is you define the destructor for the base class as virtual. Okay, so what it does is, so it basically for the derived, it automatically forces the destructor for the derived class to be. Okay, so yeah, so if you want to call the destructor of the derived class and then base class, in such case you need to mark the base destructor as virtual. That is all you need to do. Okay, so this automatically resolves. So it basically forces the destructor to be called. Okay, so yeah, so I'll come to virtual later. Okay, so virtual is something, a feature that needs to be discussed, but this is how we work. So one thing that we need to remember is, if you want to handle pointers and if you are using inheritance with the base class and derived classes, it is better to declare your destructors for the base classes as virtual destructors. Okay, so particularly it is helpful in freeing of the memory. Okay, so that it ensures that the destructors for the derived class also are called. Yeah. Okay. So I'll wait if there is any question. Then we'll talk about polymorphism, which is where virtual is used. Okay. So they're basically virtual. Yeah.
So new keyword just allocates memory, right?
Yes. Yes.
And the type is decided by the pointer type. So how can the B pointer here access any member of the derived class?
You can just directly access. So using, so see, say it has member, say m. Okay, so int m. Okay, so now if I say b m, this will work. So the point is, this pointer b now, it will pretend like it's a pointer to the derived class. Okay, so that is allowed.
Okay, and can this be anywhere in the hierarchy? Like if I have multiple derived classes?
No, I think the higher, so this is the second level derivation. I will get clarified myself. Okay, so for the multiple level, I think it is allowed, but I don't know what are the access permissions and so on. It should be possible. See, usually the textbooks, they don't really go higher levels. Okay, so they don't really describe higher levels. So I will have to look at Stropstrom's book. Okay, so that is probably where it is done. So, but at least
And
one level, that is how it is.
and here B cannot access the private members of the base, right? It pretends as a derived class object.
Yes, yes.
Even though being a base class pointer.
No, so here I think, see, when you say pointer, I don't think it actually is. Okay, this is a very good question. Actually. I haven't thought about it. Um, See, problem is, okay, so one problem with this pointers is, right, is uh, yeah, I don't know if it really assesses the public private here, okay, completely. So at least from what I understand, it should allow even the accessing the private. Okay. No, sorry. What you're saying is right. You say when I say it's not accessing, right? So when I say M is private. Yeah, sorry. Yeah. So if you are accessing M, right? So this is the access is done by somewhere else, right? Yeah. It is anywhere. Private access is prohibited, so it won't be. Okay.
Sir, I didn't get you.
No, no, I got confused with your question. So what you're saying is this is prohibited, right? Is this prohibited or allowed? That's what your question is, right?
Like
So
I
if
don't know
I
if
do this
we can.
access, so see, the access is determined by where you are accessing. Okay. So this access is an outside access, outside the class. This is disallowed. But then how
No, no,
can, yeah.
inside the class I am talking about.
No,
Like,
inside the class, so the moment I have base pointer, right? So how do you say? So base pointer is allocated, I mean, it's pointing to memory allocation corresponding to the derived class. Okay. But then what do you mean by base accessing that?
like there would be a private member in the base class, right?
Yeah. Yeah.
So can I access those private members from the derived class because this is a base pointer object?
Oh, that was your question, is it?
Yeah,
No, that cannot be. That cannot be. So that means what you are saying is the function in the derived class, can it access the private member of the base class?
yeah.
No, no, that is not. See, this pointer basically it behaves like an object of the derived type. Okay, except for the destructor thing.
Okay, sir.
Yeah, so what I got confused is when you say the base class can it access the private member, I mean the derived class can it access, so I was thinking of this. Sorry. Okay. Yeah, so
Okay.
this is anyway not allowed because it depends on where do you access, right? So one more thing is, so now you can, so if you declare this, you can invoke all functions of the derived class as well. Okay, you can call all functions of the derived class. So b dot whatever function. These can be called. You have access to everything irrespective also, I mean if they're private function, I mean you cannot access it from outside, but if they're public function you can access. Now these functions themselves they can access, I mean the access permissions are all as usual. Okay, they are not overridden, I mean they're there as such. Yeah.
And sir, constructor of derived class would be invoked, right?
Yes. Yeah. Constructor of derived class, I mean that's what this says basically, right? You need to invoke the constructor of the derived class. So this portion, so this is constructor of the derived class. And so if you also want the constructor of the base class, the derived class constructor should specify what is the constructor to be, constructor of the base class to be called. Yeah. Okay. Yeah. Any question? So now we'll come to another important aspect, inheritance. So this is again something, I mean, like I said, I don't know what is the justification for this feature. Okay. So now you might think about this polymorphism, right? Overloading, operator overloading or function overloading. But particularly, let's think about function overloading for now. Okay. So now let's just look at this code segment. So base class has some function. Now what happens if I define the functions of the with the same name in the derived class? So will it be so overloading, that is, so this function will be overloading this function. So in that case, this segment should give a compilation error, right? Or is it the other way? So yeah. So the way C++ is implemented is it does not allow overloading across base and derived class. Okay, by default. And there is a way to achieve it, but by default it does not. So the way, if you declare void fun, so this basically, I mean, it basically hides this function. Okay, this function is gone now. So if you have a derived class and if you call this function fun, it is the function of the derived class which will be called. The base class function is gone. It's not with just with signature. If you even if you had declared with this function here with the fun some int n, even then this is not visible anymore. So there is no overloading across base and derived class. Okay, so I'll just write it here. So no overloading across base and derived class. Okay. So if any function bears the same name, then it just overrides. That means there is no overloading at all. Okay. So whatever you declare, so you can overload within this class, but not across the base class and the derived class. Okay. Yeah. So here I can overload. I can further say void fun int n, void fun int n, int n, and so on. Okay. So that is allowed. But the moment you declare a function with the same name, it is the derived class which takes it. The other the from the base class functions with the same name are hidden. They are gone. They are not inaccessible in the derived class. Okay. So this is the feature of given by C++ implementers. Okay. Yeah. So now the key thing, right? Because of the feature that we have introduced earlier. So let's go back here. So we said, okay, a base class pointer can point to a derived class, right? Now what will happen? So there are function fun defined in the base class as well as the derived class. Let's say what, okay. Now if I call here, so before delete, let's say I call here, so be fun. What do you think will happen? So you might expect that the derived classes function should be called, right? Not the base class. Yeah, but the way it is implemented, so they have implemented that. So if you call a base from a base pointer a function which is available both in the base class as well as the derived class, which are declared in both the base and derived class, it will be the base classes version which will be called. Okay, it won't be the derived class. So that is something very important to keep in mind. So if you are going to use function pointers for the of base type to point to derived class, okay, but then it will not. Yeah, a base pointer pointing to the derived class calls the base method. Okay. Yeah, that is something we need to keep in mind. But then there is a problem, right? So then what is the point of this feature as such? Why should we need this at all? So this feature is useless then. If it hides the, so if I'm just using pointer to the base class, but I have allocated memory to the derived class, but if I cannot access procedures or methods for the derived class, I can only, particularly if there is an across overloading, it's not an overloading, functions of the same name. See, all new functions here which don't have the same name here, they are available. So only if you have the functions which bear the same name, then we are in trouble. Okay. So the functions of the derived class automatically get hidden if the pointer is of base type. Okay. Yeah. So now we'll see how to overcome that. Okay. So yeah. So this is where the virtual keyword comes in. Okay. So this is where virtual is introduced. Okay. So now all we do is, for such functions, so in this case, I mean, this is for, so you can just imagine you have a base class called shape and then different kinds of shapes, rectangle, square, circle, or whatever. Okay. So all of them are derived classes. Okay. They will also have draw. Okay. Now this virtual keyword, what it does is it allows overloading. Okay. Across base derived overload. So the moment I say virtual, it says, okay, so consider this along with this. Based on the context, C++ will decide which one to be called. Or, and in fact, it is decided in the runtime. Okay, so at runtime, it is decided which one to call. Okay, so I mean, like I said, I mean, the reason why we allow base pointer to point to derived classes is basically utility. Okay, so in the sense that if you have, so in this example itself, so base class is shape, the derived could be square, circle, ellipse, whatever shapes that you have. Okay, so now draw would be a feature which is available for all of these. Okay, and shape might also have its own draw function. Let's imagine. Okay, so now it is easier if you just have one pointer and you can allocate any kinds of data, because the user can imagine user is entering the type of the shape and then entering data for the shape. Okay, so dynamically you can allocate depending on the type of the shape. Is it square or circle or any other shape? You can allocate memory according to that shape class type. Okay, but the pointer will be of shape type. But then the problem with this limitation or this feature, I mean, you can call it as feature, is if you just call draw, it will always call draw for the shape. It will not call draw for the rectangle or circle or whatever. Okay. Which is a problem which can be, like I said, which can be overcome. All you need to do is in this class shape, how to have a keyword virtual. So you just say virtual. So this declare this function as a virtual function. It enforces. So essentially what it does is across all derived classes, this can be overloaded. So you can, this essentially works like overloading. Okay, so these classes will be overloaded. Now what will happen? So now if you have any pointer type, I mean the base pointer type pointing to any of these types, circle or square, okay, so if you allocate to circle, then this procedure will be called. If you allocate to square, the corresponding procedure will be called. If it was allocation to shape type, then the procedure called will be that of shape. Okay. So, so that is how virtual is used. Okay. So yeah, it basically says, it indicates that a derived class may want to override. It's not necessary that I define, so if the base class defines a virtual class, I have to define this function of the same name. It's not really necessary. Okay. But the only thing is when a virtual method is invoked using a base pointer, so the appropriate version is invoked. That is all. C++ ensures that the appropriate version is invoked. But then what will happen if I don't, so for circle I don't define, for square I define and so on, okay? But then I declare a pointer of shape type and I allocate it to memory of circle. If I call draw, so it will call that of shape because it's not available for circle, okay? So it will just see which, I mean, so, okay, so the allocated memory is for circle type. Now, if the function was virtual, if I call draw, it will see if draw is available for circle. Okay, if yes, it will be executed. If not, the draw for shape will be executed. Okay, that is how it works. So now I hope it would be clear about destructor, right? It essentially has the same functionality. So the moment we declare the destructor to be virtual, what it does is if the allocated memory for some derived class, so this virtual keyword, I mean, because of the function is declared as virtual, it will enforce it to look for, okay, which is a relevant function. So in that context, the allocated memory is 2 of a derived class, then the destructor for the derived will be counted. Okay. Okay, so I'll stop today's recording. Yeah, maybe I think a couple of questions on the record. And after that, we'll stop the record. So we'll experiment on this inheritance issues. Questions asked by some of you. So this is again Mr.